In our first unit on the Pythagorean theorem, we've started out trying to really understand squares and square roots, and we've used area models to try to do that. Our learning outcomes, the things we're trying to be able to do, is firstly to be able to identify square numbers, secondly to determine the square root of a perfect square number, and then thirdly, to estimate the square root of an imperfect square number. So some of the key points that you've learned while we've been doing these exercises is firstly that a perfect square is a number that is the product of two identical whole number factors. So it's the result of a multiplication statement where the two numbers being multiplied are identical whole numbers. So in this example, the perfect square is 25, and it's the result or the product of 5 being multiplied by itself. So 5 is the identical factors, and the perfect square is 25. An imperfect square is a number that is the product of two irrational factors. So the factors are still identical. So factor 1 and factor 2 is identical. They're being multiplied together, but they're not whole numbers. They are irrational numbers, decimals that don't terminate. So you can see in the example, 20 is an imperfect square and its factors are irrational, 4.4 with some continuation on the decimal. So sometimes the terminology can get a little bit confusing, and you can see you could be asked for the square of a number. The square of a number, if you're being asked to determine the square of a number, you're being asked to find the area of a square whose side length is that number. So for example, if you're trying to find the square of the number 5, you're trying to find the area of a square whose side length is 5. So in this case, the square of 5 is 25. So 5 times 5 is 25. If you're being asked to find the square root of a number, then you're trying to find the side length of a square whose area is the number. So the square root of 25 is 5 because 25 is the area of a square with a side length of 5. So square of a number is talking about area, and square root of a number is talking about the side length of a square. So the square root of 25 is 5. How do we estimate square roots of imperfect squares? We use the perfect squares on either side of the imperfect square number. The square root of the imperfect square will be a decimal between the square roots of those perfect squares. So, for example, 27 is an imperfect square between the perfect squares of 25 and 36. The square root of 25 is 5. The square root of 36 is 6. Therefore, 27, square root of 27 is a decimal number somewhere between 5 and 6, but closer to 5 because 27 is closer to 25. Therefore, I estimate the square root of 27 to be approximately equal to 5.2. Then there are a few little tricks for determining the square roots of large numbers without a calculator. So for example, if you were asked to determine the square root of 6400, you can break it down into two factors. So 6400 is the same as 64 times 100. And therefore, the square root of 6400 is going to be equal to the square root of 64 times by the square root of 100. The square root of 64 is 8. The square root of 100 is 10. 8 times 10 is 80. Therefore, the square root of 6400 is 80. How about determining the square root of fractions? So, for example, if you were asked to determine the square root of 1 over 16, you would first, that's the same as finding the square root of 1 over finding the square root of 16. So the square root of 1 is 1, and the square root of 16 is 4. Therefore, the square root of 1 over 16 is equal to 1 over 4. What about determining the square roots of decimals? So, for example, if you were asked to determine the square root of 0.16, well, the first thing that I would do is rewrite that decimal as a fraction. So 0.16 is the same as 16 in the numerator and then 100 in the denominator. And I know that it's 100 because I need to have the same number of zeros in my denominator as what I have decimal points behind, or decimal places behind my decimal point. So the square root of 0.16 is the same as the square root of 16 over 100. And then the square root of 16 is 4. The square root of 100 is 10. Therefore, the square root of 0.16 is 0.4.